Okay, recording has started. Alright. Now notice that while I went to the other screen, you couldn't see the practice quiz. But if you had OneNote, so consider it an assignment for next class if you haven't already done this. Make sure you have Microsoft Office installed on your computer. If you don't have Microsoft Office, you can get it free through the community college. Look in Module 0, it tells you directions on how to do so. In Microsoft, once you get Microsoft Office, then open up the software called OneNote. This is the software right here, OneNote. And then you click on that link that I put in the announcement, and then from now on you always have this, and you'll have all these tabs you can look through, and you can open up your own version of OneNote just before class each time. So then if I switch screens and I'm off on a different screen, you can still be looking at the quiz problem for the day. And then you have more control over what you're seeing, not just seeing exactly what I'm showing. I'm going to give 30 more seconds. Alright, let me have you stop. So on number 1, there are 2 possible problems that we have to avoid. You can't do things like this, square root of negative 9. It's not 3 because 3 times 3 is positive 9. It's not negative 3 because negative 3 times negative 3 is positive 9. And you can't do positive 3 times negative 3 because that's not a number times itself. So you can't have any negative numbers inside the square root. You also cannot have something like this, 4 divided by 0. If you tried to put a number like 0, this times this does not equal this. It doesn't check. You cannot have 0. And so, in fact, remember when we might have mentioned this. I have 4 classes, I can't remember. One of the best ways to conceive of 8 divided by 2 is how many times bigger 8 is than 2, or how many times you have to add 2 to itself to get to 8. You have to add 2 to itself 4 times to get to 8. You add 0 to itself an infinite number of times and you never get past 0. This is impossible. So we have to avoid both of these problems here. So thus the domain can't be negative numbers, and it can't be, normally 0 is okay inside a square root, but in this case not. X is greater than 0. Not greater than or equal to, because if it's equal to 0, you get 0 in the bottom of the denominator. Can't be negative, that avoids it. Now this is a partial solution. It's not in interval notation though. So better than this, to put it in interval notation, is 0, comma, infinity. X greater than or equal to 0 would look in interval notation like this. You use a bracket when you include the endpoint, a parenthesis not including the endpoint. Infinity, we never get to infinity, that's why it always has a parenthesis around it, right there. So that's number 1, the domain using interval notation. Let's go to number 2. Same direction. State the domain using interval notation for this one. I'm going to give you a minute here. 30 seconds more. Okay, let me have you stop. Now this problem doesn't have square roots like this one does. So we don't have to worry about, eliminating the negative numbers. And you can get fractions. Anything is fine as long as the only problem this one could have is only one possible problem. Can't have 0 in the denominator. You can have 0 in the numerator, that's fine. Now, I can't tell what's going to cause the denominator to be 0 until I do one thing to this. If I factor it out, x, the two numbers that I put second have to multiply to be positive, so they must be both positive or both negative. I want them both positive, so I get a positive middle term. And then two numbers that multiply to be 2, it's pretty simple, 2 and 1, so we can do that. And then the two middle terms will be 2x plus 1x, so it'll be 3x, so that will work out right. Now, the simple way to state the domain is the domain can be everything except, what's the number that causes x plus 2 to be 0? When x is negative 2. What's the number that causes x plus 1 to be 0? When x is negative 1. So that's the domain stated in a very simple way. But the directions were, state the domain using interval notation. So practicing interval notation, we would write the domain this way. Now on a number line, here's 0, here's negative 1, here's negative 2. Alright, it's, on the number line it would be all of this, everything between here and here, and then all of this. Thus, it's this part way to the left is, we have to go, now some people write it negative 2 comma negative infinity. See, it's negative infinity on the left side, positive infinity on the right side. But you can't go negative 2 comma negative infinity. It has to be from left to right, just like we read from left to right. The numbers have to move from left to right. So it's got to go negative infinity, comma negative 2. And then when there's more than one set, you could say the word or in symbols we use union. Union, negative 2, negative 1. Union, negative 1, 0. That's the full answer. So, if everybody can give me some feedback on these two problems. Were these rough for you? Did you need a while just to get oriented? Was it good practice? Or you got it down? Or where are you at in terms of these two problems? And everybody go ahead and type something in. Okay, and if you found some part of the review really helpful, that's really good to know. If you didn't need the review, it's also good to know. Same directions. State the domain using interval notation. The next problem, h of x is the square root of x minus 6. Excuse me. Okay, 15 seconds more. Okay, on this one, the domain is, well, a couple ways I can go about it. I can just try for trial and error. I'd say, suppose x is 2. Is that okay? Well, no, because I'd get a negative 4. Can't take the square root of that. And if x is any negative number, I can't do it. And if x is a small number, I can't do it. If x is 5, I can't do it, because I'd get a negative. The first number I can possibly do is 6. And so I say x, and I can do 7 and so on, because I get 1. So my first attempt might be something like this. X is greater than 6. But then I would ask myself, what about 6 itself? Can I take the square root of 0? When x is 6, I get 0 inside the square root. Square root of 0 is 0, because 0 times 0 is 0, so I have to put greater than or equal to. And then if I want to state it in interval notation, it is 6, comma, infinity, with a bracket around the 6. Okay. Now, that's one way to do it, trial and error. The other way to do it is you think of what's inside the square root as one result. You know, once you figure out what x is and plug it in, you're going to get one number here. This one number must be greater than or equal to 0, because it's inside a square root. If it's negative, it won't work. And then I solve this inequality just like I solve an equation. I'm going to get the same thing. Okay. Let's go to the next one. State the domain and the range. And this time we have it from a graph. Let me blow this up a little bit. Okay, 30 seconds more. So the domain is you're going to really ask how far left and right does the graph go. For the range, you're going to be asking how low and how high does the graph go. If, for instance, I said, all right, if x is 2, what's the output? You'd go to 2, and you'd say, well, there's no output for x is 2, because 2 is not part of the domain. When you go straight up or straight down from 2, you don't intersect the graph. So the domain is from what? From 4. Now, 4, I want to include the endpoint. All the way to 8, but don't include that endpoint because it's an open circle. And the range, how low to how high does this graph go? Now, the lowest point is 2, but actually it can never equal 2. Highest it goes is 8, but it can get to a height of 8, like this. All right, give me feedback on both of these problems. The domain of H, and then domain and range of this other one. Okay, seeing that it was helpful is a good comment too. That lets me know something important. And you can always write like need more practice. That's also really good feedback. Beverly, try closing out Discord and coming back in again. And if that doesn't work, you might even reboot your computer before coming back in again. All right. When there's an arrow instead of a point on the graph, let's look at that. Because, all right, neither of my practice problems have that. So let me change this next one to this. We're going to do this next one, and let's change it so that it goes right through here. And then comes up forever. Like this. Alright, so this is going to be the next problem. State, same direction, state the domain and the range. Oh, I have different directions for this. Let's just do this one, though, without those directions. Let's do domain and range. So we get one where there's an arrow. Because somebody made that point, that's a very good point. Okay, 15 seconds more. So, the domain, I'm going to say how far left. Like if I have x is -5, there's no output. negative 4, as far left as I can go. How far right can I go? Forever. Infinity. And then the range. Looks like this comes down to negative 1 as the lowest point. And then how high does it go? Well, this looks like it goes up forever to infinity. Okay. So that would be the first part of number 3. All right. Now let's do find f of 1. And now this, for these answers, f of 1 and find all x so that f of x equal 1, use just the original portion that was in the graph. Ignore this extra part that I put in when you answer A and B. Okay, let me have you stop. Before I do this, let me go over something. Look at this point right here. This is, it looks like f of 3 is equal to 1, or really close to 1. What this is saying is the input always comes in parentheses right after the f, and you find that along the x-axis. The output is alone on the other side, and that's along the y-axis. When you see find f of 1, this is saying that the 1 is the x. That's the input. And you look for it along the x-axis, and then you go straight up or straight down till you hit the graph. When you hit it right here, you look at its height. And it's going to be about, I don't know, maybe 1.8. Something like that. Fairly close to 2. So answers can vary a little bit. The next one, find all x. I'm getting some feedback. I think, let's go check here. Somebody not muted. All right, I think they're muted now. All right. Find all x so that f of x is equal to 1. Notice inputs are in parentheses, that's the x. The output, or the height, is all alone. So the input is x, and the 1 is now in the output position. So here is output of 1. So what I'm going to do is I'm going to make a horizontal line. Height of 1. And what I'm looking for is, what's the input? That's going to give me an output of 1. There are 2 such. There's one of them right over here. And that's going to be about, what, negative 2.7? That's an input that will give me an output of a height of 1. And there's another one on the right, which is, looks like about 3. Now, there'd be yet another one if we went way over here, but I told you to ignore that part for this because we don't have an x scale way out here. Okay, so we get more than one answer here, and getting used to the distinction on these two types of questions, very important. All right, so give me feedback on these two problems. Oh, I think, yeah, no, it's just these two. When we had the infinity, and then this part over here. Was there one of those parts that was especially difficult for you that you really needed to review? Or both? Okay, Maya says, I thought f of 1 was x, not y. When you type f of 1, the x is 1, and then whatever the height is that is straight up or straight down from f of 1 is then the y. Alright, so let me review that again. F of 1 would be 1.8 because, again, the x is whatever is in the parentheses. Like f of 3 is equal to 1. F of 1, and then to the right is 1.8. Alright, let's go now to number 4. And let's get rid of some of these. Oh no. Do this differently because I'm overlapping. Alright, so solve these two inequalities and put your answer in interval notation. Number 4. Try to move this down. Okay, to fix that in a minute. So I'll do both of those problems, that inequality problems. Okay, 30 seconds more. Okay, let me try to fix So, number 4. We solve inequalities just like we solve equations. So, I'm going to subtract 2. I get 3x is less than or equal to 12. Now, when I have 3x is less than or equal to 12, I'm going to divide both sides by 3. And then I get x is less than or equal to 4. Put my answer in interval notation. Now, x is less than or equal to 4 on a number line. It looks like this. Filled in circle at 4 and everything to the left. Now, when I put that in interval notation, it's negative infinity on the left, but I don't write 4 comma negative infinity. I have to go left to right. And infinity is never included, but the 4 is included. That would be my answer right here. All right, so that's this one.
Can I quickly ask a question?
Mm-hmm.
I feel like I remember something about solving inequalities where you had to flip the sign.
Yes.
When does that happen?
Yeah, I was wondering about that too.
All right, what's your name?
Lydia.
Lydia. Lydia, you are anticipating exactly what we need to be doing, and it shows up in this next problem. And it's when you, this one, to solve this one, I have to get rid of the negative 2 to get x by itself. The negative 2 is multiplied by the x, so I'm going to divide both sides by negative 2. But when you multiply or divide both sides by a negative number, you have to flip the inequality. So what I do is I whack it out. And then the next time I write it, it's going to be x go the other direction. X is less than negative 4. Now, let me explain why we have to do that. Because it doesn't have to be a rule that you just memorize and then you soon forget because you don't understand why it works. All right. So, why did we have to switch the sign when we divided, or if we multiply, both sides by a negative number? All right, so why switch the sign? All right, I'm going to give you something. Does everybody agree that this is true? 5 is greater than 2. All right, now I'm going to do something to both sides. And will I still get a true statement? So this is true. Let's suppose I add 10 to both sides. So let me go plus 10 to plus 10. It's still true. 15 is greater than 12. Let's suppose I multiply both sides by 3. That's still true. 15 is greater than 6. But there is something I can do to both sides where it will no longer be true. And I'm going to ask anybody know what I could do to both sides, and this will no longer be a true statement? Just go ahead and hit your microphone and tell me. Anybody see it? Something I can do to both sides and it won't be true anymore.
Multiply by a negative?
Mm-hmm. That's it. Let's do it by the simplest negative I can think of. Negative 1. Notice I'll get negative 5 and negative 2. Who has more money? The one who only owes $2 or the one who owes 5? It's now got to be reversed. That's smaller. That's the bigger one. When you multiply or divide both sides by a negative number, it reverses the inequality. And let me show you this idea graphically. If I had a number line like this, here's 0, here's 2, here's 5. Now, the number 2 can be thought of as this, an arrow going out this far. The number 5 can be thought of like this. When you multiply both sides by a positive number, there's still going to be arrows pointing to the right. But when you multiply both sides by a negative number, suppose you multiply both sides by negative 1, then I'll keep this here for a second. If you multiply both sides by negative 1, it just turns this thing around. And turns this thing around. And so the one who was further to the right, which was the larger one, now becomes further to the left, and it's the smaller one. And we can kind of think of this too in terms of, before there was money. When you got married, you borrowed 2 cows from your parents, or from a relative or something, so you could start your own farm, male and female, and so on. But if somebody was ambitious, they might borrow 5 cows. But if they had a reversal of fortune, and some disaster happened, and they lost, disease went through and killed off all their animals, they'd go from having the best situation, 5 cows, to having the worst situation of owing somebody 5 cows and having nothing. That negative just flips them all around. And so that's why there's this, when you multiply or divide by a negative number, the sign of the inequality has to switch at the same time. Now, the reason why I'm going over this is because when we were doing domain and range, one of the ways you can do domain and range is set up an inequality, like we did right over here. Say this must be greater or equal to 0. But if this has like a negative 2x minus 6, then when you solve that inequality, you have to remember that rule, that when you multiply or divide by a negative number, you switch the sign. All right, so let's go to the next one. This is 4. It changed my number. This is really, it does this all the time. Changes numbers. This is number 5. Find the slope of a line that contains these 2 points. Give everybody a minute. Okay, 30 seconds more. Okay, I'm going to have you stop. So, might be a long time since you've done slope. A refresher on formula, it's the change in y over the change in x, or y2 minus y1 over x2 minus x1, where we might think of this as the first point, x1, y1. This is the second point. They get subscripts of 2, x sub 2, y sub 2. So then the difference in the y coordinates over the difference in the x coordinates. 7. The slope is 7. Alright, so give me feedback on these last two. Number 4, which is inequalities, solving inequalities, and number 5, which is slope between 2 points. Alright, so we are at a break point, so we will start again at 1:30. Anybody that has a question can talk to me now or type it in. And try to clean this up.
Mr. Shankin,
Yes.
I missed the beginning of this class.
Uh-huh.
There was a lot of traffic and road work up where I live, and
Okay.
my internet's not very good there. So I got it about 10 minutes late.
Okay, and I recorded it, so you can go, give about an hour or two after the class is done and the recording will be up. And then you can go and see what you missed.
Okay, thank you.
What's your
This
name?
is Beverly. This is Beverly.
Okay, great. Thanks, Beverly, for letting me know.
Mr. Shankin.
Yes.
This is Ian. I was also here late. But I got my bike stolen, so yeah.
Okay, thanks for letting me know, Ian. And,
Yeah, of course.
take care.
Thank you.
All right, welcome back. We'll start again. So one of the questions that was asked to me was about if you have some difficulties with Canvas or anything gives you problems, you can email directly. Like if an assignment, it's much easier for me to grade assignments in Canvas. But if you had some difficulty, and when we come to test time, if there's something that ever comes up, if you're taking the test and you're a parent and one of your kids needs you and there's just no choice, then you just send me an email, let me know, and then, you might not be able to upload it because the time deadline is passed, but then you could just email it to me. And the priority is not following all the rules. The priority is that you understand the material and that you're able to have success and show me that you understand the material in this class. And all right, let's go back here. So we've done a number of practice quiz problems, and now are there questions on the homework? The practice quiz problems might have cleared up some issues for you. But if there's still questions on homework, you can either type them into the chat or you can just use the voice, and tell me by voice. Either one. Any leftover homework questions? All right. If not, then we're going to skip this one till later if time. Let's go to the next section. 3.3. Rates of change and behavior of graphs. All right. So the first situation is this chart. IBM stock starts on day 3 at $20 per share. So you see this point, 3 days over, $20 up. On day 6, 6 days over, it's $41 per share, 41 up. Now, how fast is the stock rising in price? This is called the average rate of change. How fast is it increasing in price? Now, you may have no idea how to answer that question, but what I want you to do is make your best guess on that. So, get into your group channel and start typing in your answer, your best guess, but don't hit enter yet. So the other group members can't see your answer until I give you the cue. Then you'll hit enter, and then you're going to discuss this and come up with the best answer your group can come up with. But work on it individually right now. Okay, go ahead and hit enter and check out what everybody in your group is saying about this. Discuss it in your group, and I'll call on a group in just a little bit. 30 seconds more. Okay, before I call on a group, let me remind group leaders, one of your jobs each day is to remind the group who the spokesman for the day is. So if you haven't already done that, please do that right now. Roughly, we're rotating by alphabetical order by first name, and any group is free to change it to whatever order they want to do it. All right, so group 2, what do you have? And if you could identify, first time you speak for your group, identify your name, first name, please.
This is Destiny, and we said it would be an average increase of $7 per day.
How did you get that?
I don't actually know. That's just what the consensus is, because I got something different, but...
Okay. All right. Now, let's go with that. 7. And the units, let me change color. The units is dollars per day. Let's see if that would work. If you started on day 3 at 20, then at day 4 you went up 7, you'd be at 27. And then if you added 7 again, the next day at day 5, that would put you at
34. And then 41, so it would work.
34, and then 7 more would give you 41. That's right. So this would be 20. If you went up by $7 a day, now this should look more like a straight line. I didn't do it very good. This, let me clean these points up a little bit. All right. That seems to work. Now, this is called the average rate of change. Did anybody do it by a different method than kind of like, because we could just go like this, and so anybody can hit their microphone, turn the microphone on. Let me know if you got the same answer, 7, but had a specific procedure that you followed that led you to 7. Nobody? Yes.
I did 6 minus 3, which came out to 3, and then 41 minus 20, which came out to sorry, hang on. Which came out to 21, and then so I did the amount of change divided by the number of days, and I got 7.
All right. From day 3 to day 6 is 3 days. From a price of $20 to a price of $41 is $21. This is what we're going to call the run. This is what we're going to call the rise. Okay, and what we're going to get is if you took the slope between these 2 points. Now this is actually a point in space way over here, because it's 3 over 20 up. This is a point in space, 6 over 41 up. If you did the slope, which is rise over run, or y2 minus y1, x2 minus x1. And this is the same problem that we did in the practice quiz too. 41 minus 20 over 6 minus 3, 21 over 3, which is 7. And these were dollar amounts, the y's were dollars. And these were days, and so the units is dollars per day again. All right. It turns out that when we found the average rate of change, how fast something is going on average when it goes from here to here, it's also the slope. The slope means the average rate. It means how fast something is going up or going down. All right, now let's look at this situation. At day 3, it's $20 per share. At day 6, it's $41 per share. Same 2 points. But notice how it got there. Almost all of the increase was in that first day. Even the first half of the first day. And then it stayed relatively the same through the rest. All right. So the question here, once again, is find, let me type it in. Find the average rate of change. I'll give you a minute to work on this individually. And as you're working it out individually, type in your answer, but don't hit enter for your group. If you're really not sure, make sure you take a guess though. Take a risk, take a guess. Okay, go ahead and hit enter and look at everybody else's answers, and I'll call in a group in a moment. All right, group 1, what did you get?
We did the same thing sorry.
Okay.
This, just like I said last time.
Okay.
Sorry. Just like I did last time, we did the 6 minus 3 to get the amount of days, and then 41 minus 20 to get the amount of change, and then we divided the 21 by 3 to get 7.
All right, it's exactly the same answer, $7 per day. And it's kind of a trick question because you think, oh, something's got to be different because look at, I did it all. But no, the point that we're making here is that the average rate of change doesn't care how you got there. If you went through the roof, went to $500 and then came back down to 41, it doesn't matter. It only depends on the endpoints. So we're going to get exactly the same answer. Average rate of change is as if you went in a straight line. Because look at these dots would go up as if we had gone in a straight line from here to here. That's what we call the average rate of change, and then the slope of that line is how fast it's increasing, or the average rate of change. Okay. Now, there's a conclusion here. When you are finding the average rate of change, how would you state, kind of summarizing what's going on here? When you're finding the average rate of change, so everybody go ahead and type something in, but don't hit enter yet. "15 seconds more." Okay, go ahead and hit enter. Check what your group, what other people are saying. Okay, you don't have to pick yours. You can pick anything that you see in your group or as you discuss it. Group 3. Remember to introduce yourself. It's the first time speaking for today. What did you get, Group 3? Anybody there in Group 3? All right, Group 4. What do you have? Y'all hearing me? You can always say pass if you don't know what the answer is. But give me some kind of... Group 4? Is there a Group 5? Yes. Yeah, we go all the way to Group 6. Okay. Group 5. What do you got?
This is Lydia.
Yes.
And I thought that the average would stay the same since it's an average.
So, restate that again.
I mean, so what's the question?
When you're finding the average rate of change, what comment would you write?
What do you mean?
Could be anything about average rate of change. So I see why you're, and why I'm getting reluctant responses here. It's kind of vague, isn't it? Like,
A little bit.
yeah,
but,
what are you supposed to put down here? Do you have anything?
I guess I would just say, like, if we're working with a graph and we don't have specific points, if only 2 points are given, like,
Yes.
I guess we can't assume that the graph is a line. Like, it could have any kind of change in between those 2 points that we don't know about.
Very good.
Like, it's not necessarily a straight line, but the rate of change can just be calculated from those 2 points.
That's right. All right. I like the way you say that we can't assume that it was going up in a straight line. But the average rate of change So let me just put something in here so that you can all put something in your notes for this. When you are finding the average rate of change, it doesn't matter how you went from the initial point to the final point. It doesn't matter. The average rate of change is as if you went in a straight line between the points. And now but it probably didn't really happen that way. Average rate of change says if we went in a straight line from here to here, the slope would be this. If you rose $7 a day, you'd get from here to here. But it probably didn't happen that way. May well have happened something like this. Average rate of change doesn't care. It just gives you the slope of that average. All right. And let's go down to another type of problem now. And this one looks simple, but the answer is kind of tricky. Find where f is increasing. So let me give everybody a minute with this. Again, type your answer in with your group, but don't hit enter yet. Now, if you're disoriented about what does it mean if it's increasing, think of f as maybe like a stock market curve for a minute. A part of this would be like, oh, it goes into negative, and stock market can't go to a negative price. That's unrealistic. But if you think of it as a stock market curve for a bit, you might think, all right, when would I be happy if I owned this stock? When would I be sad if I owned this stock? But then trying to communicate that where it's increasing gets a little tricky. All right, go ahead and hit enter with any ideas that you have, and then discuss it in your groups for a little bit. Okay, let me see how many groups we got. All right, group 6. You can always say pass, but what do you have?
This is Joanna. We aren't sure how we're supposed to write it.
Okay, tell me, do you have a sense of where it's increasing though?
Yeah.
Where?
One of us said at point
4, -1 is where it starts increasing.
Ah, it starts increasing down here. Yep. Is that the only place it's increasing?
And at like 1 and then maybe like 0.5.
Yeah, way over here. And this is going infinitely far to the left. So it's actually increasing infinitely far to the left up to here. Right? And come on, up to that point. So all this part is increasing and is increasing way over here. All right, excellent. You have an intuitive idea of where it's increasing. But how do we communicate this is really what we got to get really precise about. All right. And let me tell you 2 ways that we could communicate where it's increasing. One first way is not correct. If we stated where it's increasing by giving an interval along the y-axis, see, first of all, you don't want to state it by points. Because you could say, oh, it's increasing from 4, -1 over to the right. And that's kind of an awkward way of stating it, but it kind of gets the point across. But you don't have a left point over here to say where it starts from, because it goes off to -infinity. So instead of doing it, we just state intervals along either of the axes. But we don't use the y-axis. And let me tell you why we don't use the y-axis. For instance, here it is increasing from when here y is -1 and it goes forever up here. So we might be tempted to say, oh, from -1 to infinity. Because from this height all the way on up, it's there. But when you use an interval along the y-axis, you would also include this region right over here. Because this is also above the height of -1. And it would also give me this region right here. And then with the curve continued further down to the left, it wouldn't include that, but it would include all of this stuff. And what you have is, if you tried it with an interval along the y-axis, you do not get a single region. You get 3 parts of the curve, and 2 parts are increasing, and this part in the middle is decreasing, and this doesn't work at all. But what does work is if we took an interval intervals along the x-axis. Then, so intervals along the x-axis, for this leftmost interval, it goes up to 2. Now, how far left does it go? It goes infinitely far to the left. So we'd say from -infinity up to 2. Then we'd also say union. You could use the word or. And then from 4 on the x-axis all the way on out, 4 to infinity. This tells me where f is increasing. Notice on the x-axis, let me get gray, from -infinity is way over here to -2. It actually isn't a bar over here because it goes infinitely far to the left. But you can see that between these 2 bars, there's only one portion of the graph. It's not like in the y-axis. If you go in the interval on the y-axis, you intersect the graph multiple times. But if you take an interval along the x-axis, remember, this is a function. Functions have to pass the vertical line test. Because it passes the vertical line test, if you give a region along the x-axis, you'll be guaranteed to get only one portion of the curve. See? And then between 4 and out to the right forever, 4 to infinity, there's only one portion of the curve here as well. So this is the most efficient way to state where is f increasing? Right here. This solves this dilemma of how I can tell where it's increasing, but how do I communicate that? You give intervals along the x-axis. Okay? And typically that's done in interval notation. It didn't have to be an interval notation. You could have said x is greater than 4. But more often we do it in interval notation. Now, you might have a question of, well, what about at 4 itself? Well, at 4 itself, notice the graph isn't going uphill, nor is it going downhill. It's at the very bottom of the hill. It's transitioning right there. We wouldn't say that it's decreasing, nor we say it's increasing. So we don't include that. That's why it's a parenthesis instead of a bracket. Same thing at 2. Right at 2, we say it's tangent line. If the line just nicks the curve, it would be horizontal right there. It's not going uphill, it's not going downhill, so it's transitioning from one to the other. All right, now you can see if we can put this, see how well you understand it by putting it to work with this next question. Find where f is decreasing. So go ahead and write that. And put it in interval notation. Type it in for your group, but don't hit enter yet. Okay, go ahead and hit enter and discuss it briefly in your group. Okay, group 1, where is f decreasing?
This is Vanessa from group 1. We think that f decreases from 2 to 4.
And what should I put? Parentheses or brackets?
Brackets.
Now, if we do brackets, that means it includes the endpoints, which means we're saying it's decreasing at 2, but actually it's not going downhill at 2, it's going horizontal at 2. So you're really close. 2 and 4 is right, but let's put parentheses saying don't include the endpoints. Where is f decreasing? Between 2 and 4, but not at the endpoints. That's where it's transitioning. Okay. And on the homework, actually, I don't get fussy about that. I don't even mark it wrong if you put brackets instead of parentheses for decreasing and increasing. What I'm really interested in is, are you getting the points correct? All right. And this reminds me of a study that I read. And interrupt me and tell me if I've already told you this, because I have 4 different classes that I teach, so sometimes I've already said a story, and please tell me if I've already told you this. So it was a college algebra class that was studied, and the people in the study had recognized two different types of teaching style. One teaching style was where the teachers never asked the students to do something without first showing them an example. They said, here's how you do the problem, now you do one. And that was one style of teaching. The other style of teaching was more like my style, where it was asking students to take risks and to take a guess at things, and writing things down without necessarily teaching them how to do it first, and then trying to access their own intuition and then revise it and so on. And what the study did was 5 years later, they approached these students one at a time, and they said, here is a problem that's a kind of a typical college algebra problem. Can you do it? And what they got was from the teaching style that was that never asked them to do anything unless they had already shown them an example. The students in that class, their typical response was they refused to pick up their pencil. They said, oh, I used to know how to do that, and if you show me how to do it, I'll do it. And the other group, their typical response was they picked up their pencil and they dove right into it. And some of them could do it, and some of them couldn't. And the study brings up the issue of perhaps more harm was done than good in the first college algebra class. It's learned passivity of don't do anything, don't make any move, and plus they didn't have great recall, and they lost the ability to play with things, to kind of figure it out on their own. So in this class, what's more important, way more important than getting correct answers, is taking risks. And that's what I look for, and in fact, a good wrong answer is much better for me, because I want you to make the kind of mistakes that you would make on the homework. I want you to make them in class, and I want them to be exposed in class so that they don't show up so much on your homework. So that we resolve those issues during class here. And that's the value that I'm going to be placing here in this class, is taking the risk is the thing that's really valuable here. And it's what I'm going to ask you repeatedly to do. Okay. Also, group leaders, make sure that you have notified who in your group is the spokesman for the day, and if no response comes up, within about 5 seconds or so, then go ahead and group leader, go ahead and respond for the group. Okay. Go to this one, number 4. Find average rate of change. Okay, 15 seconds more. All right, let me have you stop. So what we're going to find when we find the average rate of change is we're going to find the slope of this line that goes through those 2 points. And it doesn't matter what in reality the path was between those 2 points, we're going to find the slope. And that slope is the difference in the y's over the difference in the x's and it's right there. So what that also means is if you were going from 1 to 4 to 3, 4, every time you move to the right 1, if you went up 2/3, right 1 up 2/3, right 1 up 2/3, it would take you from the first point to the last point. Just like we saw when we did the sevens. You went right 1 up 7, right 1 up 7, that would take you from the first to the last point. That's what the slope will do between those 2 points right there. And it's also this. This was the run right here of 3. And this was the rise from a height, no, the run, yeah, the rise of 2. So the ratio of this to this, 2 to 3, is how much you do each time. Every time you move 1 to the right, go up 2/3. You'll do it. Okay, now let's go to B. All we have is 2 points in a table. Find the rate of change. And then there's C. All we have is this equation on an interval, 1 to 4. All right, we are running out of time here, so I'm going to do these last two. So the B, find, because the same directions, it's find the average rate of change. So I'm going to find the average rate of change. It's a slope. And it's the difference in the y coordinates over the difference in the x coordinates. I'm going to point out that I could have done the difference in the y coordinates using the top one first. I could have done this one. If I use the top one first here, I have to use the top one first down here. Now this is -7, and then those become positive, so it becomes 3, so it's -7/3. This becomes 7 over -3, but in the end it becomes the same thing, -7/3. So you get the same answer no matter which order you put these in. Now, this last one, find the average rate of change on interval 1 to 4. This on interval 1 to 4 means x is between 1 and 4. So if x was between 1 and 4, we could see it like it's on a table. If x was 1 all the way to 4. If x was 1, we plug a 1 in here. We get 3 minus 1 squared, which is 2. If x is 4, we plug the 4 in. We get 3 minus 16. 3 minus 16 is negative 13. Okay, so those are my 2 points. And then I am going to say that my average rate of change, is the same as the slope, which is negative 13 minus 2, the difference in the y coordinates over the difference in the x coordinates. Which is negative 5. Alright, so we are done. I always put a little bit more than I usually can get to, so that's just optional material that we didn't need to cover. The homework is 3.3. So before Thursday, have the 3.3 spot check uploaded, which is at least 75% of the same 3.3 problem set. And Thursday is also your first turn-in day. So by midnight, Thursday night, by 11:59 p.m. Thursday evening, you need to have your final versions of 3.1 and 3.2 uploaded. And also, if you missed the spot check on one of the first couple sections, go ahead and get them. You won't be able to upload them. You can just email them to me. I'll give some flexibility on this first two because I know everybody's just figuring out the new, how this system works and so on. Any questions? All right. I will see you all on Thursday.
Bye. Thank you.
You're very welcome. Okay. I've not graded any of the spot checks for correctness. I'll never do that. The spot check, I'm just looking, did you complete 75% or more? So you upload all the problems for the homework thing. There might be a time, though, when you never made any changes from your spot check. Like you did everything just the way you wanted to on the spot check. And you have it totally complete and you never found anything that you wanted to change. then you don't need to upload anything for the assignment. If I see there's nothing in the assignment, I will grade what's in the spot check then, in that case. All right. And Ava, do you have a computer where the mic doesn't ever work, or was it just malfunctioning today? I think you're gone already. Okay. Yeah, she's not here anymore. Okay. I'll send her that as an individual. Show them your thing on your phone, and because they emailed it to me, and I printed it out, and I thought I had stuck it in there. But what I can also do is, because they said they want it on a phone, and maybe they don't want a printout, is I can forward that email to you.
Well, how about, okay, or do you want to text it to me? Or you could, yeah, you could forward the email to me, and that way I would have it on my phone.
Uh-huh.
Sounds great. I think I'm in the wrong lane. Shoot, I am in the wrong lane, and I have to go.
Okay.
Okay.
I'll email it to you now. Okay, bye.